Alright, Bismillahirrahmanirrahim. Assalamualaikum. So today we're going to continue on our syllabus, chapter number 3, under discrete random variable, a probability distribution for discrete random variable. Last class we already looked at the probability distribution for discrete random variable. We already understand basically the concept of probability distribution, right? So basically there are two rules in probability distribution function, which is probability distribution function should, the value of probability distribution function should more than 0 or less than 1, and the total summation of distribution function should always equal to 1, right? And the notation for probability distribution function for discrete random variable is probability of px equal to x. And we also have been introduced on the concept of random variable, right? So today we're going to continue on the cumulative distribution function or cumulative function, right? Cumulative function basically is the same concept as cumulative frequency, right? Last class we already on the second chapter we already been introduced on the frequency table, right? So on frequency table we have basically the x value, and we have frequency value, and the last one we have cumulative frequency, and the symbol for cumulative frequency is capital F. If you can relate this symbol, if you are trying to find probability distribution, so we're going to use fx, the small letter f. If you want to find a cumulative function, we're going to use capital letter F, right? And the concept of cumulative frequency, let's say I put this one as let's say 40 to 50, 50 to 60, 60 to 70, 70 to 80 contoh for example. So for let's say frequency, I letak dekat sini. This is 2, 5, 6, and this is 4. So let's say total semua ni berapa? Let's say 17, right? This is total. This is the frequency kan. If you want to find a cumulative frequency, so you should always start before the first class, right? Cumulative frequency start before the first class. So the first class, before the first class, the cumulative frequency equal to 0, and the frequency also equal to 0, and this one should less than 40. When x is less than 40, then no frequency available, right? And when x is more than 70, more than or equal to 70, then the cumulative frequency always equal to 1, right? Because 70 and above, right? So if you want to find the cumulative frequency for the first row, first class, 0 plus 2 equal to 2. It means that kalau you nampak dia punya concept dekat sini, if you can expand the concept, right? Expand the concept dekat sini, means that if you want to find cumulative frequency, right, for the first row, means that frequency before the first row plus frequency of the first row. Nampak tak? This is a frequency before the first row, 0. Frequency of the first row is 2. Sorry. Kalau kita buat sini, tambah dari sini ke sini kan, means that the cumulative frequency. This is a cumulative frequency. Capital F minus 1 plus F1. So you dapat F1. If you want to find cumulative frequency for number 2, means that cumulative frequency number 1 plus frequency number 2. Can you understand the concept? I just expand this in a mathematical form. Right? So nampak kat sini, means that dekat sini dia akan jadi apa? Cumulative frequency number 1, which is 2, plus frequency of row number 2, which is 5, which is equal to 7. 2 plus 5 equal to 7. Right? So the range here, kalau kita tengok dekat sini, range dekat this one, it means that is between 50 to 40, 40 to 50. Right? Boleh faham? So, since kita akan menggunakan less than method, if you still remember on less than or give, right? So, kita akan notation dekat sini less than 50. So, this one should be less than 60. Right? So, for number 3, cumulative frequency for number 3, row number 3, cumulative frequency row number 2 before the row number 3 plus frequency number 3. So this one should be 7 plus 6 equal to 13. And this one should be less than 70. And the last one, let's say cumulative frequency, this one 13, right? Cumulative frequency number 4, which is cumulative frequency number 3 plus frequency of number 4. So 13 plus 4 equal to 17. So this one should be equal to 17. Right? Boleh? So I hope you understand the concept. So this one, either we can put less than 80 or more than or equal to 70. Right? So normally kita akan put like this lah, more than or equal to 70. Right? Should be equal to 17. So this is a basic concept of cumulative frequency. Right? So from the concept of cumulative frequency, we're going to transform this concept, right? This concept into the probability distribution. Probability distribution function, which is a cumulative function, right, for discrete random variable. So this is applicable for discrete random variable. So now let's look at the introduction for cumulative function. Alternate approach to express the probability distribution of a random variable is to measure probability with a real number x, which provide the probability that x is less than or equal to x. So kita nampak dekat sini, x less than or equal to x or more than. This scenario makes most statisticians agree to use notation capital Fx to indicate the probability of x is less than or equal to x. Nampak tak? So apa kita tengok daripada cumulative frequency table, right? So this one, row number 1, let's say kita tengok row number 1, it indicate that probability x less than 50. Right? X less than 50. So boleh faham? Boleh faham apa yang saya cuba sampaikan di sini? Kita nak express, nak tengok apa definition dekat sini sama tak dengan konsep yang saya bawa ni. So, kalau kita nak tengok the first cumulative frequency for 0, means that before the first row, which is this one lah. Right? Which is this one. Right? So, it means that the range there, probability of x less than 40. So it should be equal to 0. Kalau kita nak cari probability of the first one, F1, it means that probability of X less than 50, which is equal to something lah. You need to calculate this one. Right? So based on the trend here, small less than, except the last row is actually less than lah. Actually probability of X less than 80. Ataupun kita boleh kata probability of X more than or equal to 70. Right? Between 70 to 80. Right? So benda yang sama. So means that setiap cumulative frequency, we are expressing the cumulative frequency in terms of probability of X less than or equal to X. So I hope you understand the concept. This is a very basic concept, right? So now, look at the definition. So the cumulative distribution, capital Fx, is a discrete of a discrete random variable x with a probability distribution x is equal to cumulative frequency is equal to probability of x less than or equal to x. This is the formula. It means that it's a summation from the lowest value to x. Is a summation of random number from the lowest value to x. Nampak tak? From the lowest value to x. Maksudnya kalau kita ambil dekat sini, cumulative frequency for number 1, from the lowest value is 40 to 50. So this is should be inclusive. Except the first one lah. First one dia tak inclusive lah because 40 in row number 1. Okay? So now, let's look at the theorem. The theorem says that the value of capital Fx, which is a cumulative frequency, cumulative probability distribution of the distribution function of a discrete random variable x must satisfy the following condition. Means the lowest cumulative distribution function value should always equal to 0. And the largest cumulative distribution function should always equal to 1. Nampak tak macam tadi saya cakap tadi? It's starting from 0 until 1. Kalau kita expand this one, right? Let's say I expand this one, I measure the cumulative frequency. Dekat sini dekat sini I tambah satu. Let's say I choose purple. So dekat sini I try to convert this to cumulative frequency. Let's say capital Fx. So 0 divided by 17 should always equal to 0. 2 divided by 17 dapat berapa? 2 divided by 17 should be, let's say kita letak dalam bentuk fraction lah. 2 divided by 17, and then this 17 divided by 7 divided by 17, 13 divided by 17, and 17 divided by 17. This one should always equal to 1, and this one should always equal to 0. Means the minimum value should always equal to 1, and the maximum value should always equal to, the minimum value should always equal to 0, the maximum value should always equal to 1. So this is the concept, right? So it's actually easy to understand because you already understand the concept of frequency table, right? So if you confuse about the notation for cumulative function, always refer back to the frequency table, right? So now the second theorem is when A is less than B, then the cumulative of A is always less than cumulative distribution for B, right? let's say 1 is less than 2. So the value of cumulative distribution function for A should always less than value of cumulative distribution for B. Right? So now, this concept is I already explained here. Kalau you tak faham this one, you can refer this one. It's actually the same concept, right? I don't want to repeat the same thing, right? This one also, okay. Look at this one. So, since we already know, let's say I copy this one. Okay. Nampak? So, benda yang sama, I ulang. I just nak tunjuk this one. This concept. I just want to explain this concept. Concept number, this one. Right. So, since we already understand the concept of cumulative frequency table, so to display the cumulative distribution function, right, before that, you still remember, to display the distribution function, a probability distribution function, we express in a table, right? Remember, last lecture, if you want to express the probability distribution function, we express it in a table, right? In this table, we have a random number and a probability distribution and probability value. For the distribution function, cumulative distribution function, we are expressing the probability distribution function by this in this form, right? So first kita letak capital F X equal to, right, at the big curly bracket. You start with the lowest value. The lowest value is capital F0. Right? Capital F0 should always equal to 0. And then we move to capital F1. So kita tengoklah sini ada berapa? 1, 2, 3, 4. Right? Capital F2, capital F3, and capital F4. And if you remember here, capital F4, row number 4, the probability is always equal to 1. So, nampak tak dekat sini? Right? So, next, dekat sini, di sebelah sini, we always express the range of the random variable. Right? So, kita tengok dekat sini, for number 1, it less than 40. So, X is less than 40. Number 2 is 2 over 17. For row number 1, right? For row number 1 is 2 over 17. So this one should be X less than or equal to 50. Kita ambil the concept of less than. Right? And number 2 is 7 over 17. It should be X less than or equal to 60. And number 3 is 13 over 17. X is less than or equal to 70. For the last one, is always equal to 1. 17 divided by 17 is equal to 1. X is more than 70. Okay, so this is how we express the cumulative distribution function. Okay, and the graph for distribution function is just like an ogive graph. Kita selalu dia bentuk macam ni lah. So dia akan makin lama makin meningkat. So this is a capital Fx and this is going to be a class boundary. right? So it's always increasing. So now let's look at example number 3.10. So before we go to example number 3.10, do you have any questions so far? Ada soalan tak? Soalan? Ada soalan, speak up. I tak dengar you cakap apa. You dah cakap ke? Alright, good. So now let's look at example number 3.10. In example number 3.10, it says that find the cumulative distribution function, right? Cumulative distribution function of a random variable x that the probability distribution function of x is as follows. So this is a probability distribution function. So you must know how to differentiate the probability distribution function and the cumulative probability distribution function. It's just same concept of frequency table, right? So remember concept of frequency table, we have frequency value and cumulative frequency. So the frequency value is just same as probability distribution function. Cumulative frequency is just same as the concept of cumulative distribution function, right? So means that here this is the probability of x equal to 0, and this is the probability of x equal to 1, and this is the probability of x equal to 2, right? So by using the standard template, right, kita dah ada standard template tadi kan, you nampak tadi template yang kita ada ni, this one, right? Kita convertkan this one to this one. So remember, as I said before, cumulative frequency start before the first class. So you always start with 0 and with 1. Right? So when x is equal to 0 means before the first frequency, first class, x is less than 0. Means, so now sebab kita nampak kat sini, the random number is equal to 0, x less than 0. So for the first, kalau nak senang kan, kita convert lah, bagi nampak vertical punya table. So kita nampak dia punya shape dia lah. This is x, this is fx from 0, 1, 2. And then we have total. So senang nak nampak, right? So this is 3 over 28, this is 15 over 28, 4 over 14. And capital Fx, kita buat macam ni. Kan senang? Okay, this one starting from 0, atas 0 kan? This is 3 over 28, and then 3 over 28 plus 15 over 28 should be equal to 9 over 14, and this one should be equal to 1. Alright. So next kita tulis ni lah 3 per 28. So this one should range between 0 to 1. Right? Because the next row is 1, right? So of course dia 0 is inclusive and less than 1. So 1 in dalam the next row. And then the next column, the next row is 9 over 14. So this is 1 less than, the next one is 2, right? And the last one is equal to 1. So satu dekat sini lah, which is x is more than or equal to 2. So this is how we present the cumulative distribution function. Okay, so I hope you understand this one. Okay, so now let's look at example number 3.11. In example number 3.11, we have, let's say we want to find a cumulative distribution of a random variable x. We know that for probability distribution for x equal to 0 is 1 over 16. And so on, they're giving you the probability distribution function. So the best way, right, to construct a frequency table, right? You construct a frequency table so you can understand the flow. So this is f x and this is capital F x. So you start from 0, 1, 2, 3, 4, and the last is total. Right. Next step, you letak dia punya probability value. This is 1 over 16, this is 1 over 4, this is 3 over 8, and this is 1 over 4, 1 over 16. And the total should always equal to 1 because the rule of probability, summation of all probability equal to 1. And cumulative frequency start before the first class. So this is 0 plus 1 over 16, this is 1 over 16. This is 1 over 16 plus 1 over 4. I hope this calculation is correct. 5 over 16, 11 over 16, 15 over 16 and equal to 1. Right? So, kita buat macam ni lah. This is a step. Fx starting from 0 where x is less than 0. This is x less than 0. This is x is less than or equal less than 0 is inclusive, x less than 1. This is 1 is inclusive, and then 2. This is 2 inclusive, less than 3. And this is 3 inclusive, less than 4. And then this is x more than or equal to 4. So you just plug in the value here. Right? Boleh? Ada soalan tak? Okay, good. So, so page example number 3.11, you boleh tengok lah, right? So, but before you go to example number 3.11, let's look at the theorem, right? This theorem. If a range of random variable x consists of value x1 less than x2 less than x3 until xn, means that if you want to find the probability distribution for x number 1, it should equal to capital F x number 1. Sama konsep lah. F1 is equal to capital F1. So kalau kita nampak, kita bawa dia punya konsep. Always refer to cumulative frequency table. Right. So kalau nampak kat sini, fx1 means first row, right? Dia sama. Probability distribution sama dengan cumulative distribution. Right? So, kita tengok the second theorem. If you want to find fxi is equal to capital Fxi minus capital Fxi minus 1. Apa maksud ni? Means that if you want to find, let's say, probability distribution for number 2. Right? We are focusing on this row. Right? So means that we are taking the cumulative frequency, cumulative distribution function for number 2, which is 11 over 16, minus before row number 2, means that 5 over 16. It should be equal to 3 over 8. Right, this is the concept lah. Right, I hope you understand the formula. Boleh ya? So if you understand the concept, then if you want to do a programming, you just type your own programming function lah. You don't need to use ready-made ataupun you don't know. Kalau you use a library, sometimes you tak tahu siapa yang buat library tu, either the calculation is correct or not. So if you understand the concept, then easy for you to develop your own code, right? So you can see on example number 3.11, right? And di sini I dah tunjuk dekat you. Now let's look at example number 2. Example number 2. Okay. Need extra example. So a random variable x, assume the value of so dia ada macam ni, -1, 0 and 1 with a probability 1 over 3, 1 over 2 and 1 over 6 respectively. So find distribution function of determine the distribution of x. Means that you need to calculate or construct a cumulative distribution function. So first step, always draw a frequency table. So this is very basic, right? So this is your x, this is your fx, and this is your capital Fx. Starting from -1, 0, 1. And last is total. Okay. So this one, fx, -1 is 1 over 3. And this is 1 over 2, 1 over 16, 1 over 6. And of course, kalau kita guna frequency cumulative function is always equal to 0, always equal to 1, and before the first row it should always equal to 0, and cumulative frequency for the first row always equal to the probability of the first row, and this one should be berapa? 1 over 3 plus 1 over 2 is equal to 5 over 6. Right? So dekat sini apa maksud dia? Dekat sini dia punya range dia macam mana? This is when x is less than -1. When x -1 is inclusive, x 0. And this one 0 is inclusive less than 1. And this is x is more than or equal to 1. So plug in the value dalam template dia lah. So this is the template starting from 0, 1 over 3, 5 over 6 and 1. So this one should be x less than -1, and then this is -1 less than or equal to until 0, and this is 0, x 1, this is x more than or equal to 1. Right? Easy, right? Easy once you understand the concept. Concept dia starting from the fundamental concept, frequency table. So as I said before lah, earlier in the first lecture, if you don't understand the fundamental concept, then you won't able to do or understand the next topic lah. So kalau nak tak faham this one, terus nak masuk to understand this one, you tak faham. Right? Okay. Ada soalan? Soalan?
No, sir. I don't think anyone has any questions.
Alright, for the next topic, which is expected value for discrete random variable. This is the second last topic for chapter number 3, right? But if you're in your book, if you refer to your book, this is going to be in chapter number 5.1. In your syllabus is under chapter number 3. Right, the expected value of a discrete random variable. Right, so basically we already learned in chapter number 2, we have learned the concept of measure of central tendency. We have learned how to calculate mean and standard deviation and also variance. So we will repeat the same concept to calculate mean, variance and standard deviation in this chapter, but in different way, right? So last chapter we calculate the mean and standard deviation based on the frequency table, based on the frequency value. But in this chapter we are going to calculate mean and standard deviation or variance based on the probability value, right? So now let's look at the definition. Let x be a discrete random variable and small letter fx is the value of its probability distribution at x, random number x. Then the expected value of this random variable is noted as expected of x equal to the summation of x multiplied with fx. So the concept here, we're going to multiply x and fx. The summation of x multiplied with fx is equal to expected of x, where expected of x is equal to mean, right? Equal to mean or mu, right? So now let's look at example number 5.1. So example number 5.1, given the following probability distribution function for a discrete random variable, we have this is a probability distribution function. And to confirm that this is a probability distribution function, we need to total all the probability value. The total should be equal to 1. And each value should be between 0 and 1, right? So to calculate the expected of x, which is equal to mean, so we're going to use summation of x multiplied with fx. From this is xi, xi. So I is equal to 0. This is the lowest value. The maximum value until 6. So this one should be 0 multiplied with 0.1, right, for the first one, plus 1 multiplied with 0.15 plus 2 multiplied with 0.2 plus 3 multiplied with 0.25 plus 4 0.2 plus 5 0.06 plus 6 multiplied with 0.04, right? So this one should equal to 2.64. So this is the answer for expected of x, and this is how we calculate expected of x. Okay, now the same concept, if you want to find the expected of x square. So now tengok ini soalan dia, jawab example number 5.3. So if you want to find expected of x, we're going to use expected of x is equal to summation of x multiplied with fx. Right? where xi, this is from 0, I equal to 0 to 2. If you want to find expected of x square, means that you're going to do a summation x square multiply with fx. This is I, this is I. So whatever inside the bracket going to be the coefficient of this one. Okay. So kalau kita tengok dekat sini, if you want to find expected of x, so 0 multiply with 0.2, which is the first one. 1 multiply with 0.6, 2 multiply with 0.2, and plus everything should be equal to 1. If you want to find expected of x square, so 0 squared. You nampak dekat sini, 0 squared. So because this is x square, 1 squared, 2 squared, and everything are following the same concept lah. 0 squared multiply with 0.2 for the first one, 1 squared multiply with 0.6 for the second one, 2 squared multiply with 0.2 for the second one. So the total of this one is equal to 1.4. And we know that this is our mean, which is equal to mu. Mean is equal to mu. This is a population mean, symbol for population mean. If you want to find variance of x, or equal to sigma squared, is equal to expected of x square minus expected of x, and then you square. So this is the formula for finding variance. So let's look at the next page. Dekat sini lah dia tulis let x have a probability distribution with probability of x equal to x and the expected value of x, expected of x equal to mu. Then the variance of x is defined as variance of x, expected of x square minus expected of x, and then you square, right? And you need to remember expected of x square is not equal to expected of x and then you square. It's totally different value. So now, let's look at this example since we already calculate this example. If you want to find variance of x, so expected of x square is 1.4. So minus expected of x is 1, and then you square. Right, so this one should be 1 squared is always equal to 1, so 0.4. So variance of x is equal to 0.4. And standard deviation, if you still remember last topic, standard deviation is equal to square root of variance. So it means that square root of variance, square root of 0.4. Square root of 0.4 is equal to 0.2. Is it? Sorry, 0.6. 0.632. Right. Okay. So this is how we find standard deviation and variance. And please remember the formula. This is very simple. Now let's look at this topic. Still under expectation, right? Let x is a discrete random variable and fx is a value of its distribution function. Then the expected value of a random variable gx is given by expected of gx equal to summation of gx multiply with fx. Easy to remember. Expected of x is equal to x multiply with fx. So whatever in the bracket will be the coefficient of the function. of the probability value. So let's look at another example. X square. This is what we already learned just now. Summation of x square multiplied with fx. So whatever in the bracket will be the coefficient value. So if you have expected of 3x square plus 2, it should equal to summation of 3x square plus 2 multiplied with fx. So this is going to be a big bracket. So whatever in the bracket will be the coefficient. So this is what the formula is trying to tell us lah. Whatever in this function is, let's say we want to find expected of some value, so that function will be multiplied with the probability value. Now let's look at example number 5.4. If x is a number of point roll with a balanced die, find the expected value of gx equal to 3x square plus 1. So this is the table. So dia ambil table dekat sini, the balanced die, right? So balanced die we have 1, 2, 3, 4, 5, 6 outcome, right? So each outcome having a same probability 1 over 6. So this is under uniform distribution. Later on we will learn about this. So now this is a probability distribution. We want to find expected of 3x. Sorry, I tak lagi pada mula. We want to find expected of gx, where expected of gx equal to expected of 3x square plus 1. So this one should be expected of summation of 3x square plus 1 multiply with fx. Seems complicated, right? So kalau you tengok dekat sini, how you calculate the expected value is very complicated, right? So this is the answer lah. And you just plug in the value when x equal to 1 squared plus 1 multiply 1 over 6. When x equal to 2, 3 multiply with 2 power of 2 plus 1 multiply 1 over 6 until x equal to 6. 3 multiply with 6 power of 2 plus 1 multiply 1 over 6. Kan? So now, let's look at some rule of expectation and some rule of variance. Right? So now, when we want to find the expected of constant, it should always equal to constant. Means that when we want to find expected of 9 is also equal to 9. Expected of any value 4, it should equal to 4. Expected of number, it should be equal to number. And then for the second one, expected of, let's say cx, maksudnya 3x. It should equal to 3 expected of x. So maksudnya the number, coefficient tu kita boleh letak kat depan. Right? So kalau kita dapat satu lagi, let's say expected of 9x. It should be equal to 9 multiply with expected of x. Right? Let's look at this one. Expected of cx plus d means that expected of 3x plus 9. For example, c and d is a number lah. Right? Is equal to 3 expected of x plus 9. So macam kita keluarkan x expected tu 1. Right? And the number kita boleh kali saja macam biasa. Right? Right, and yang yang nombor 4 ni sama je lah. Nombor 4 dan nombor 5 sama konsep the first one. Right. For example, this one, expected of 3x plus 9. Right. It should be 3 dekat luar, then expected of 3x plus 9. So, kita keluarkan lagi 3 expected of x plus 9. So, you multiply. Right. So, benda yang sama. So, now let's look at the variance. When we have variance of constant, variance of 3 is always equal to 0. Variance of 9 is also equal to 0. Variance of any number is equal to 0. Any number without the parameter is equal to, without the variable is equal to 0. And so now let's look at this one. Variance of Cx. Right? Variance of Cx, like for example, variance 3x is equal to 3 power of 2 variance of x. This is the formula. So means that any number that you yang ada pair dengan variable, when you take out, the number will be squared. Right? Variance of 9x should be 9 power of 2 variance of x. And then let's look at this one. Tadi saya tak tunjuk lagi satu. Dekat atas ni saya tunjuk tambah kan. Right? Dekat atas ni saya tunjuk tambah kan. Let's say this one. Yep. Expected of 3x minus 9. Tadi ni tambah. This is plus. This one is minus. Right? So it should be equal to 3 expected of x minus 9. It follows. Right? They follow dia punya notation. But for variance of x plus 3, for example, right, is equal to variance x. So plus 3 ni is equal to 0 because variance of constant is equal to 0. What if you have variance of 3x plus 9? It should be equal to 3 power of 2 variance x plus 0. So 9 is a variance of 9, variance of number is equal to 0. Okay. What if kalau you ada variance of 3x, let's say I repeat sekali, 3x square plus 3 plus 9x lah. Kita ambil dua variable, senang nampak. Variance of 3x plus 9y. It should be equal to 3 power of 2 variance of x plus 9 power of 2 variance of y. What if you have variance of 3x minus 9y? It should be 3 square variance of x plus 9 square variance of y. You can spot the difference. The difference is whatever notation you have, either plus or minus, it should always become plus. Right. So let's go back to that question. Right, this question. Okay, since we want to find expected of 3x squared plus 1, so we no need to do a complicated calculation like this, right? So when you do a complicated equation, then you have a high chance to commit with the mistake, right? So this one should be equal to 3 expected of x squared plus 1. So now it's easy for you to find expected of x squared instead of this calculation, right? So it should be equal to, kalau you ada calculator kan, do you have this calculator? 570ES, 570ES, right? So now Using this calculator, you cari summation. Ada tak? This calculator, where is my calculator? You cari summation. Where is summation? This one. So tekan shift, summation. Right? And then you put x square. This is x. And then square. Since the value are all equal, right? The value are all equal. So you just put 1 over, you need to multiply with 1 over 6. From 0 to, sorry, this is not from 0, it's from 1 to 6. Right? So tekan sama dengan, it should be equal to, okay, 15.16. 15.16. 67 lah, 67. So once you already have the value, just plug in the value into the formula. So expected of 3x squared plus 1 is equal to 3 multiplied with 15.167 plus 1 is equal to berapa? Just multiply lah, 3115.167 plus 1 is equal to 46.501. Okay? Boleh Right. Any questions so far before we proceed with the example? Exercise yang kita ada ni? So, for question number 3, let's say, I think you already know how to do it lah. Right. So determine the value of m. So we already determined the value of m is equal to 0.24. Right. So this is 0.24, 0.24. So now it's easy for us to find expected of y. Right. So the expected of y should be 7 multiplied with 0.15 plus 8 multiplied with 0.24 plus 9 multiplied with 0.24 plus 10 multiplied with 0.22 plus 11 multiplied with 0.15. So you just plug in the value into the formula and then calculate. So you will get the expected of y. Okay? So I hope you still have the question, right? Soalan yang sama juga. So as I will leave this for you as an exercise, take home exercise. You do it by yourself, right? And you cross check with your team member, right? Kalau dapat jawapan sama, it's okay lah. Right? If you don't understand, you can ask me later. So before I end the session, do you have any questions so far? Ada soalan? If you have a question, speak out. If you don't have a question, also speak up.
No, sir, no questions. No, sir.
Alright, I think that's all. Thank you very much. Assalamualaikum.